everybody. Hello there, ROS developers, and welcome to a new open class. So today we are in open class number 185 already, and today we are going to be checking and playing a little bit with Foxglove, which is a very interesting tool for visualization, debugging of robotics projects. We will be checking it in a moment, but before that, just say welcome to all of you, and please let me know if everything is fine, if sound is fine, video is fine, so that I can continue without worrying about it. So yeah, then let me already switch here to my computer screen so that I can start having here the chat and everything. So let me do that right now. Let's see, there we go. All right, so let me already log in into the platform. Let me go here to the open class page. Let's see, everything is good so far. All right, so hello Gilbert, Michael, Jonathan, he's confirming that everything is fine. Also Francisco, Gilbert. Okay, excellent. Then yeah, so welcome everybody to a new open class. I hope that you are going to enjoy this one. And yeah, so as always, before getting started, the very first step that you have to do is to get the project for today's class. All right, so how to do this? Very easy. All you have to do is to come here right above the chat, and you are going to find this button which says fork and open the class project. So I'm going to click here myself. Let's go for that. Then as soon as you do this, let's go for that, two things are going to happen. First of all, as you can see, you are going to be redirected to the main project page, which is this one I have here. Here at the right side, you have the streaming panel with the video, the chat, and everything. I'm going to actually remove this so that I have more space for my project, which right now is loading. All right, so this might take some seconds to fully load. We'll come back in a moment here. But also, I want to let you know that whenever you click on that button, a copy of this project is copied to your account. All right, so to find it, all you have to do is to come here to the construct and go to the My Projects section here, yeah, in the left menu. So if you go here, you are going to see that a copy of the project has been created here, and this copy you are going to have it in your account forever. All right, so not only for today's class, but if you want to open it again to review it tomorrow, next week, next month, you are going to have this project in your account. All right? Okay. Then actually, let me open here the open class page so that I have the chat here and I can be checking all your messages, questions, feedback, etc. And yeah, so let me go back now to my project screen. Then whenever this loads, you are going to get something like this. Yeah, this is the main project page, and in your case, you are going to see that automatically the notebook is opened. Yeah, this is the Jupyter notebook where you are going to find all the instructions, code, images, everything that we are going to be doing during today's class. You have it here in the project, okay? I'm going to be following these instructions, but here you have everything detailed. All right? So, yeah, basically that's it for the setup of the class. As you already know, if you are a live class and open class veteran, is that these classes are 100% interactive, okay? So all the attendants, so all of you should get a copy of this project, because this is going to allow you to practice along with me. All right, so you are not just going to be there watching and listening to what I am doing or saying, but you are going to be actually practicing in real time, yeah? So these classes are fully interactive, so I want you guys to be involved, to be trying out everything, and let me know your feedback in the chat if you have any questions, problems, feedback, whatever. All right? So first of all, I would like to ask you, have you, all of you, been able to get the project? Have you opened the project? Are you here in the same page as I am? Any issues so far? Yes, yes. Okay, so it seems that so far so good. No issue so far. Excellent. Then we are ready to get started. So the very first thing that we are going to do is to launch a simulation, okay? So the goal of today is to create a basic, let's say, control center for our robot based on a web, yeah? So we are going to create a web-based control center or monitor center for our robot, in this case a TurtleBot3, okay? Then, first of all, do you guys know about Foxglove? Do you know about it? Have you used it before? Not at all? First time hearing the word? Ernesto says that he doesn't know Foxglove. I used it for a bit, says Walleling. Okay. No. Jeff says that he knows about it, but he has not used it yet. Gilbert has done even an interview with them for usability. For reading ROS back data, I know a bit. Okay, so a bit of everything. It's all right. So in case that you have heard about it, then you are going to have the chance today to work a little bit more with it. And if not, you are going to get introduced to it, and maybe you are going to see if it's suitable for your project, etc. All right? Then, okay, so the very first thing that we are going to do is to start up our robot. Yeah, so if we want to create a control center for our robot, we first need to have a robot. In this case, we are going to be working with a simulated robot, all right, which is going to be a TurtleBot3. And in order to launch it, to start our robot, what we have to do is to execute this command that you have here in the notebook. Yeah, it says execute in terminal 1. All right, so in order to execute these commands, we need a terminal, first of all. So in order to open a terminal, you have to click on the first icon here, which says Web Shell in the bottom menu. Yeah, so you click in this icon here for the Web Shell, and this is going to open a new terminal. All right, this is a regular Linux terminal where you can type commands and so on. And in this case, the commands that we are going to execute are these. So I'm going to copy these commands directly here from the notebook and paste them here to the terminal. So first we source our ROS2 workspace, and then we execute this ROS2 launch command to start the simulation. Let's go. Let's go for it. Let's wait a few seconds. In some cases, maybe the first time that you execute the simulation, it can fail, okay? Let's have a look here at our case. So as you can see here, Gazebo is automatically opened, and let me get a top view here. Okay, so it seems like in my case the simulation has loaded properly. Yeah, here I have the environment. Here, this is the TurtleBot3 robot. So it seems that it has worked. In some cases, maybe you can see the world, but you cannot see the robot. Okay, don't worry about the robot being white. This is how we have it like this. We are not really loading here the meshes and so on, just for simplicity reasons. In any case, if you have any problem, all you have to do is to Control-C. You stop your simulation by pressing Control-C in the terminal, and then you just execute the command again, and the second time is going to load properly the Gazebo simulation. All right? So there we go. Yeah, here we have our simulation, the world with the robot. If you want to make sure that everything is working properly, you can open another terminal by clicking on this plus icon here, which says create new terminal. Yeah, so this is going to open a second terminal. And here, for instance, you can type a ROS2 topic list and check that you have the robot topics available here, which you can see command bell, odometry, the scan for the laser, yeah? So if everything is okay, you should be able to see here all these topics. All right? Okay, so first step is done, which is to start up our robot, in this case, start up our simulation. All right? Okay, now here we have a second step, which is to start a navigation system. Okay? So for this robot, we have prepared already a simulation, a navigation, a nav2 system, which is everything configured and so on. So I'm not going to get into the details of how this works, but here basically you have a command to automatically start the navigation system for this robot. Okay? Actually, I'm not going to start this yet. I will wait for a bit until later when we are going to be interacting with the navigation system from Foxglove. Okay? So for now, I'm going to skip this step. Then let me keep scrolling down to here. So what is Foxglove? Then I can see that most of you probably in the chat said that you have heard about it, but basically in just a few words, Foxglove is an open source visualization and debugging tool that is very useful in robotics projects. So, in other words, in case that you have not heard about Foxglove, you have probably heard about ROS, right? ROS is the typical tool that every person that has worked with ROS has used it at some point. So Foxglove, we can say that it's something similar as ROS, in the sense that it allows you to visualize laser information, sensor information. It allows you to debug also some issues related to your robot. Then Foxglove is similar to this, but it provides a much more higher level of customization. Also, it allows you, for instance, which is what we are going to be doing today, to create a visualization center, a monitor center in the web, which is web-based, okay? Which can be also very convenient for some projects. So, what are we going to do? The next step is going to be to set up Foxglove, all right? Then the very first thing that we need to do is to install this Foxglove bridge, okay? This bridge basically is going to create a bridge between ROS and Foxglove, okay? So that we can visualize and we can connect to the ROS data from Foxglove, all right? Then, yeah, so let's execute these commands. We are going to execute first an apt get update in our system to get the latest package. We can do this here, for instance. We run an update and then we are going to install the Foxglove bridge package. Once the update is finished, there we go. Now we run the install. Okay, here we can see the package is being installed. ROS Humble Foxglove Bridge. All right, there we go. So Foxglove bridge package installed. So now what we are going to do basically is to create a launch file in order to start this Foxglove bridge. Okay, so very simple, just in a few steps. We are going to go inside our ROS2 workspace, src folder and create a new ROS2 package named TurtleBot bring up. Okay, so let me execute these commands right here to create the package. By the way, at this point, I'm going to suggest all of you to open the code editor. Okay, we are starting to create new packages. We are going to be creating new files, etc. So for this, it's much more convenient to use the code editor. So in order to open the code editor, all you have to do is to click on the button here in the icon, which is next to the terminal, which says code editor. You can click here and this is going to open, as you can see, the code editor, which is going to allow you to interact with all the different workspaces, files, folders that you have in this project. Yeah. For instance, if you go inside the src folder of the ROS2 workspace, you are going to find here the new package that you have just created, this TurtleBot bring up. Okay? Yep. So, next step, we are going to update the CMake list file of our package. So if you go inside the TurtleBot bring up package, you are going to see this CMake lists.txt file. So what we are going to do here is to basically remove the contents from here, and you can copy directly here from the notebook the contents and paste them. Okay? Basically, the only thing that we have added here is this section here, which is basically used to install inside the workspace the launch folder, which is a folder that, by the way, we have not created yet, right? So this is what we are going to do right now to create this new folder. Then we have the commands here to do so from the terminal. Also, you can create it directly from the code editor by right-click on the package and select new folder, for instance, and then we put the name of the new folder, which is going to be launch. Okay, there you go. And now, inside the launch folder, we are going to create a new launch file named turtlebot.launch. Yeah, so for this, you can just right-click on the folder and select new file, and then just enter the name of the launch file, which is going to be, in this case, turtlebot.launch. Okay, you can rename it for better, I don't know, bridge, for instance, turtlebot_bridge. Yeah, to know exactly that here is where we are going to be launching the Foxglove bridge. There we go. Okay, and finally, all we have to do is to put something inside the launch file, which it's going to be this. Okay, so you select this from the notebook, copy and paste into the launch file. Yeah, and as you can see, all that we are doing here in this launch file is to start the Foxglove bridge launch file from the Foxglove bridge package that we have just installed. Yeah, and then in this case also we are redirecting to the port 9090. Yeah. And basically, that's it, all right? So now what we have to do is to build our package, and we are ready to execute it. So let's get the command, let's copy the command from here and execute them in order to build our package, the package that we have just created with Qualcomm build. There we go. Let me actually rename here the terminal so that I know what I have in every terminal. This is the simulation. This is where I'm going to be running the bridge. There we go, bridge. Okay, so now just source and execute. Oh yeah, in my case it's not TurtleBot because I have renamed the launch file, so it's TurtleBot bridge. Okay, and there we go. So here I am running the Foxglove bridge. Okay, so at this point I am already ready to connect my robot with Foxglove. Yeah. So for that, what I'm going to need is a specific address that you can get in the project by typing the following keyword, which is ROS bridge address. Okay, if you copy this keyword here and execute it in a terminal, let me put this a bit bigger, you are going to get an address like this, which is a WebSocket address. Okay, so what to do with this? Very easy. As the notebook indicates, now we can go to the Foxglove webpage, which is by following this link that you have here, foxglove.dev. Let me click here. Now, at this point, you should create an account, okay? If you already have an account, you can just log in. If you don't have an account, you can create one. Now, I'm going to sign in here with my Google account, for instance. There we go, okay? And then once you are logged in, you should see something like this. Okay, so at this point, the only remaining thing is to click on the Open Connection here in the left menu in the dashboard. You have Open Connection. And now here in Foxglove WebSocket, you remove the current URL and you paste the one provided by the ROSjet, by the ROS bridge address. Yeah? So you can select and copy this URL, okay? And then paste it here into the WebSocket URL in Foxglove, like this. And then just click in Open. And that's it. The connection is established, okay? Probably you are going to start seeing some things. Here in my case, I can see the frames of the robot, even the camera I have started seeing here. I'm going to remove it. Okay. Yeah. And that's it. So right now, I am connected here from Foxglove in the web to my robot. Okay. Yeah? How is it going? Let me check here. Tisas is asking also, how is everything following so far? So, how are you doing? Are you following so far? Any questions, problems, issues? This is the most important part, okay? To establish the connection. From this point, basically what we are going to be doing is to customizing everything. Michael says so far so good. Also, Walleling. Okay, also for Rafael. Excellent. Ernesto also says that it's working for him. Okay, great. So let's get started. Now what we are going to do is to start modifying a little bit here the different tools that we want to visualize. Yeah. So now what we are going to do is to actually create our command, our control center for our robot. Yeah. So what do we want to add here? Okay, so we are going to now be checking some of the most typical things that we want to monitor from our robot, okay? Here are, by the way, all the instructions are, as you can see that I have been doing myself, everything is explained here in the notebook, okay? So you are going to find everything step by step here. Okay, I'm just going on my own because I already know all this. So I am skipping it, but in case that you want to review some particular step, you have everything in the notebook, okay? So now we are basically at this point, yeah? We have established the connection. So what we are going to do is to customize the Foxglove interface for our robot. So, okay, so actually let me start from zero. I'm going to remove everything, okay? So basically right now I have nothing here. Let me remove everything. That's it, okay? So I have nothing. So I'm going to start adding things one by one. So the very first thing that I'm going to add is a new panel, yeah? In order to add new panels, you have to click on this icon here in the top left corner, which says Add Panel, yeah? And here you have all the different panels that you can add. So the first one that we are going to add is a 3D panel for visualizing our robot. There we go, okay? Then here, if you click on the panel, you are going to have different things to customize it here in the left area, okay? For instance, here you have the display frame. You can select which transforms to visualize. For instance, here I have a mess of frames, so I'm going to click on the three dots, hide all, and then now I'm going to select only the ones that I want to visualize, which are going to be, for instance, base link and odometry, okay? There we go. Now, in the topics, you can select which topics to visualize, okay? Now, here we are going to add two for our center. First of all, it's the robot description. How to add a specific topic? Well, here, for every topic, at the right side, you are going to see this icon, which says toggle visibility. If you click here, basically what you do is to enable the visualization of this specific topic. In this case, robot description. Robot description topic, as you know, is used in order to basically visualize your robot, yeah? So, for instance, if I click here, I can see the representation of my robot right here, all right? Another important topic, the scan. Scan topic is, as probably most of you already know, for visualizing the laser data, yeah? So I'm going to also enable the scan data, and here I can see the laser data, okay? Yep. If you want, another thing that you can add, for instance, is the camera, but I don't recommend to do it like this. Later, we are going to do it in another way, okay? Because like this is going to generate something a bit strange. So later, we are going to add a specific display for the camera, okay? Yeah? So basically, here with the 3D panel, what we are going to be checking is two things: the robot description, to get a view of our robot, and also the laser data. Okay? If you check the simulation, by the way, you are going to see that the laser readings that you get here basically are equivalent with what we have here in the simulation. Yeah? Okay? So let's continue a bit more. Then, yeah, so we have added the robot model and the laser scan to the 3D view. What else? Okay, we can add a camera also, yeah? And this is very, very simple. For instance, okay, I want to also monitor what the camera is capturing. So let's add a new panel again through the Add Panel button here in the top left corner. Add Panel, and then here we select an image panel, like this one. I'm going to click here, and automatically I start capturing the data from the camera image raw topic. There we go. Okay? Yeah, for instance, if I add something here to the simulation, let me add a sphere. Maybe this is too big. Can I add something smaller? This here, for instance. Okay. As you can see, this is capturing in real time the data from the camera. Okay. I'm going to remove it now. Yeah. Okay. So, what else? Let's keep adding some things. Okay. So now we are going to interact a little bit with the navigation system. Yeah. So actually, this is not only for visualizing, but you can also send information, send data from Foxglove to the robot. For instance, what we are going to see is how to send a navigation goal from Foxglove. Okay? And this is done in a very similar way as how it is done in RVs. Okay? So, at this point, what we are going to do before starting this section, publish to map, is to launch the navigation system, okay? So let's go back to the beginning of the notebook, and here we are going to now start the navigation system with this command, okay? So let's go to the terminals, and in this third one, actually I'm going to rename it now to nav2, and now here I'm going to launch the navigation system. So copy and paste these commands. And here we should start getting all the output from the navigation system being started. Okay. There we go. And by the way, here in the notebook, you have some instructions to set RVs and so on. But in this case, I have removed this from the project, okay? Just to make things lighter, I have removed RVs, okay? Because actually we are going to be interacting directly with Foxglove. So all this part related to RVs, you can skip it, okay? You can ignore it. So I'm going to remove it here from the notebook, actually. Okay, so now we have the navigation system here running. So here, if you go back to the panel, you are going to see that in the topic section, there are many more topics that have appeared here. Okay, you have the map, the plan topics, AMCL topics, etc. So all the topics related to navigation have appeared also now here in the topics section. Okay, so for instance, one of the topics that we can try to visualize is the map topic, yeah, to see the navigation map. Then let me click here, and actually at this point I should not be able to see the map. Why? It says missing transform from frame map to frame base link. So the problem here, if I'm not mistaken, is that the display frame, I have it to base link. So let me change this to map. There we go. And this to fixed. No, the problem is in the navigation. I think that for some reason the localization has not started properly. Let me try to restart this. I'm going to try to restart the navigation system. And I'm going to remove for now also the camera display. Okay, just so that I have more resources here for the navigation system. Let's see. think there might be some issues here with the TFs. So actually what I'm going to do is to restart also the simulation. Because I'm afraid there might be issues here in terms of resources, yeah? Because the projects that we are using here are not very powerful, yes? The ones that we are using here, which are the default ones. So if we start trying to launch too many things, there might be some problems. So let me try to restart this. Let me kill the navigation here. There we go. And I'm going to probably restart also the simulation. Yeah, I think so. Let me restart everything. Okay, simulation started, and let me try to restart here navigation as well. Okay, let me refresh here Foxglove. My navigation system is not starting for some reason. Okay, let me see. Failed to listen on port 9090. Address already in use. Okay, this is probably because you have something running that is already using this port. Maybe you try it to launch the bridge more than once, Walleling. This is similar to fixed frame in RVs. Yes, exactly. We need to give initial pause. Mine is working. I tried to give initial pause from Foxglove and it works. Yeah, we can do that. We can do that. However, I change it here, the navigation, so that it sets an initial pause by default. So it shouldn't be necessary. Let me try one more time. And if not, I'm going to set the initial pause manually. And that's it. Okay? No worries. Okay, let's see. Map fix it. Let me try to refresh here. This is like not going. Let me see. Okay. Now my base link is not even appearing neither, which is weird. Okay, so let me do it normally. Where we have the navigation, here it is, param, waffle. Yeah, see, so here I'm setting the initial pose manually, but it seems like it's not getting it for some strange reason. Let me try to refresh this. Actually, let me try to re-add the panel 3D. Okay. Let's see if resetting everything helps. Hide all. Base link. Okay. I don't know why I'm not even getting the laser now. Let me restart everything. Okay. So now obviously I have lost the connection, which makes sense. There we go, simulation running. Let's see. Let's relaunch the bridge also. Okay, there we are. Okay, so now we have this working again. And I would like to give it another try like this. Yes, it should work. Let's see if restarting everything helps. But yeah, I know it should work. Activate the base link frame as well. Okay. Can we change to the map frame? We can. Can we add the map? There we go. Okay. Okay. So now this is looking good. Okay. So now we have the map with the map fixed frame here, and the robot properly localized. Okay. So you should not need to initialize to set the initial pose from Foxglove, although you can do it. But what I want to do here, instead of setting the initial pose, is to send a goal. Yeah. So how to do that? It's actually pretty simple. So what you have to do is to change here in the publish section. Yeah. So we have reviewed the topic section, and here at the bottom, you have this publish section also. Yeah. Which responds to this button here. Click to publish. Yeah. As you can see right now, this is just a button, but we can change this. And we are going to change it to be, instead of a point, a pose. Okay? So we change this to be a pose stamped, actually, which is what we use in Navigation 2 for setting goals. There we go. And in the topic, we are going to change it for what? For the following topic, which is goal_pose. Okay? This is the topic that the navigation 2 is listening to in order to receive navigation goals. Yeah. So here I'm going to remove this and change it to goal underscore pose. Okay. Yeah. So at this point, as you can see here, the click to publish point has changed to an arrow. Yeah. So now we can select anywhere in the map. For instance, I'm going to send it here. The first click is going to set the point, and the second click you can use it to set the orientation that you want. For instance, let's set this orientation. And as soon as you click, we should see the robot go there. There we go. Okay? So we can see that our robot in the simulation is actually going to the goal. And we should also see it here. But for some reason, the map is not updating. Let's refresh this. Sometimes there are some visualization issues, especially when working with the web, because we are sending all this data through the Wi-Fi and so on. What's going on here? It seems like the robot has stopped for some reason. Okay. Okay. Something, it seems like it was disconnected. Let me stop and restart things. Let me do like before. So I can see Tisas is suggesting many things here. Yeah, I think there are problems with the network. Yeah, so probably network is not very good for me, at least here, which is causing some of these issues when trying to connect with Foxglove through the network. Let's see. Okay, so this looks like it's fine now. Let's relaunch navigation. Tisas has suggested to remove the laser visualization for higher network speed. Okay, we can try that. To remove for now. Okay, here we start receiving the navigation topics, which is a good sign now. Okay. So let's try to visualize the map now. Okay, there we go. This should be fixed. Actually, I would like to change here to map view. There we go. And let's try to send the goal now. So this is goal pose. Right? If I'm not mistaken, the topic is goal pose. Yeah, goal pose. Okay. So let me actually put also here the baselink TF. Okay. This is looking good. Okay, yeah, this is because I put the topic wrong. All right, so let me try then to send again a goal here. Okay, so now it seems that without the laser, indeed, it works better. Let me add the laser now. Okay, let me remove it. Yeah. Okay, so here we can see the robot going towards the goal, also in the simulation. And it should keep going until it reaches the goal. Here we have it, okay? Goal succeeded. All right, and we can, I don't know, let's try to visualize something else. I don't know, for instance, the plan. Can we try to visualize the plan here? All right, let me send another goal around here. Yeah, I think the plan here is too much. Okay. Okay, there we go. All right. Goal succeeded. Okay. Well, so yeah, as you can see, some issues, especially when when working through a Wi-Fi network and so on. So you have to bear that in mind. But yeah, so as you can see, you can interact with the navigation system, also send goals, etc. So Tisas was suggesting to try receive a global plan. We can try that, yeah. Let's see. And send another goal. Let's send it here. Ah, yeah, this one actually shows, yeah. Okay, so what about you guys? Have you been able to have the navigation working in your setups? Following these steps? Anyone else? No success from anybody? Michael said that it worked for him at least. Rafael says no. I don't know why, but I tried to relaunch everything. Yes. Try to relaunch everything. Yes, Braden, we have started a bit ago, but you can review it later. Okay, so don't worry, because once we finish, we are going to upload it to YouTube, so you will be able to review everything. Walleline says that it's working for him too, the navigation setup. This is probably the trickiest part. Okay, as for there might be some issues because we are loading many things here. The ROSject is not very powerful in this case, so there might be some issues, as you have seen. But yeah, you should be able to have it working. Okay. Okay, and yeah, so we are almost done. There are just a few more things that we can check, because so far we have been seeing typical things such as visualizing the laser, visualizing the map, sending navigation goals to the robot, and so on. But Foxglove also provides some tools in order to debug the system. Some things very interesting, such as, well, yeah, so we have also the teleop, so we can teleoperate the robot from Foxglove. This is also very simple, so we can just at another panel, which is the Teleop panel, and it's going to look something like this. We can select it, change the topic here, which in our case it's command bell. And actually at this, let me put this here, and I'm going to stop actually now the navigation just to free some resources. Let me stop here navigation already. And I'm going to change then here and remove the map visualization. There we go. Okay. Can we recover the scan? There we go. Okay, so what can we do with this? Well, we can configure to publish commands into the command bell topic through this very simple teleoperation graphical interface. Okay, so here we can set the different values for the up button, down button, left button, and right button. Okay, we can configure this as we want. Yeah, so we can configure the publish rate, the values that we are going to be published. For instance, if I click on the up button, which is this one, I'm going to be publishing one, in this case it's meters per second, okay? This is too much, so I'm going to lower it to 0.25, for instance, okay? And I can configure this button, for instance, the down button, to publish a velocity of 0. So basically, to stop the robot, okay? What does this mean? This means that if I click on the up button, I'm going to start moving the robot forward at 0.25 meters per second. Okay? So right now I have the robot here, and I can also, of course, configure the angular velocities. For instance, let me change this to 0.5 and minus 0.5. Okay? So, actually at this point I'm going to add also an image. Let's see if I can't. Okay. Split down. I want to put this here if I can't, and remove this one. As you can see, you can configure and change everything as you want. Okay. So let me here move to the left a little bit. There we go. Stop. Can I stop? Okay. Where I am. Okay, so now if I start going forward a little bit, there we go. You can see the robot moving forward. Okay? And if I click here, what I'm going to do is to stop the robot. As you can see. Yes, so you can configure this very easily and as you want to create a very simple teleoperation tool. Okay? Yeah. And what else? What else can we do? For instance, we have very interesting debugging tools, such as topic graph visualization. Yeah. And all of this is as simple as, again, going to the Add Panel tool and select the topic graph visualization, for instance. What is this going to provide? Let's have a look. This provides something like this, which actually, let me make this, let me change the visualization and remove the services. Yeah. So what do we have here? Here we can see all the different nodes and topic connections. Okay. Yeah. So here we can see gazebo, clock topic, all the different nodes with the topics, connections. Yeah. We have also something here to plot information. Very interesting as well. So let me add a plot here. Sorry, plot. There we go. Let me put this not here. I want to split down. And this one also split down. Oh, I want to change it. Okay, more or less. And okay, so here let's subscribe, for instance. Let's try to plot here the odometry. Odometry position X. Okay, so what is this going to plot? This is going to plot the position X of the robot, and we can visualize this here in. Let me check this. Exactly. There we go. Okay, so here we are monitoring the position X of the robot. Yeah. So for instance, if I now start moving it, let me start moving here a bit the robot. Let me see here. Please provide link to replay lecture. Is it possible to connect to your server to do the lecture in the future? I don't understand very well this question, Ross, but we are going to upload the session to YouTube, okay? So you are going to be able to review it on YouTube, and you are going to be able to get the project and everything. So basically, yes, you are going to be able to redo everything on your own. Okay? Yeah? So basically, yes, we can define here the axes and everything that we want to monitor here in the plot. So yes, have you been able to reproduce all these with the teleop, the topic graph, the plot, and everything? Many more things, but yeah, so I'm going to leave it for you to explore all these and create your own monitor centers, okay? Because as you can see, there are many things that you can do here. Here we have just explored a few of them. So yeah, I'm going to leave it here, and I would like to ask you, as we are doing lately, to share your work, okay? So if you have created your own control centers, your own monitor centers for your robots, you can create them and share the images with us in our social media. We are always very happy to see our students' works. So yeah. Any questions, comments, feedback so far? Any issues? I hope that nobody is writing because all of you are there configuring your control centers here in Foxglove. If I wanted, okay, so Wallerlink says, if I wanted to have this in as a package in my local machine, how different is it. Okay, by the way, so here what we are showing is the web version of Foxglove, okay? But you can also run Foxglove as a regular application, okay? So in case that you are going to run it in your local machine, my suggestion would be that you just run it as an application, okay? This web configuration can be very useful, for instance, to create a control center of a robot like the one I am creating, and then you can save this configuration and share it very easily with whoever you want, okay? But in case that you want to just use it in your local setup, you can just run it as a regular application, okay? So let me actually share here the link to the page, or so that you can get exactly information. I don't want to run to the app. Foxglove wiki. Wiki. Docs. Okay, where is the documentation? Here it is. Okay. Yeah, so let me share this link with all of you here. There we go. Yeah, so in this case, we are working with Humble, but as Tisas is saying, you can also use it with other ROS2 distributions, okay? So it's not limited to Humble, all right? And yeah, I like the idea of the best looking setup gets a retreat. Yeah, that's an interesting idea. All right, so yeah, I think I'm going to be leaving it here if there are no more comments or questions. So yeah, thanks again to all of you for being in today's class. I hope that at least you have learned something new and you can now start playing a little bit with Foxglove and see if maybe it can be useful for some of your projects. I'm sure that it can be very interesting, at least to give it a look. And yeah, so I'm going to leave it here. Thanks again. And I will see you again next Tuesday with another open class, which it's going to be very interesting. So make sure to don't miss it. And yeah, so see you then. And as always, until then, keep pushing your ROS learning. Bye-bye.